So we've all heard of the Big Bang, where 14 billion years ago time and space were created simultaneously in a small point. We all know that the universe is currently expanding at an accelerating rate. But how much do we know about the future of the universe? Will everything we know be ripped apart as the universe expands, or will the universe collapse on itself? Essentially, there are three possibilities: the Big Freeze, the Big Rip, and the Big Crunch. I'll be going through each of these individually, but firstly, what actually differentiates between these three possibilities for the fate of our universe? It all has to do with how the universe is expanding and will continue to expand. This depends on the gravitational force pulling the universe together and the force that's causing it to expand. And this all centers around the Hubble's constant, which is the measurement of the rate of expansion of the universe. Deceivingly, though, Hubble's constant isn't really a constant, as it's changing over time. The term constant only came into play because it is used to describe that in a single moment in time, it is constant throughout the entire universe. How this constant changes through time is what will determine the future of the universe. We know that this constant is decreasing through time, but how it decreases depends on various factors. For simplicity, we will only be looking at three factors: radiation, matter, and dark energy. Firstly, if you don't know what dark energy is, don't worry, you're not alone. Even scientists haven't discovered what it actually is. But essentially, it's a term given to the source of energy which opposes the attractive force of gravity between galaxies. We know that there must be a force counteracting the force of gravity, as if not, our universe would be collapsing on itself. We simply haven't found out what it is yet, so we named it dark energy. In simple terms, just think dark energy is what causes the expansion of the universe. Now let's look at how radiation, matter, and dark energy changes as the universe expands. Matter here is just normal matter. So as the universe expands, the density of this matter will drop in a graph of a to the power of 3, and it has to be cubed due to its volume. The process of radiation diluting is a bit more complicated, but as you can see from the graph, it will drop as well. The interesting part is when we look at the energy density. Since the energy is intrinsic to space itself, the energy density will have a graph of a to the power of 0, meaning it will remain constant. Now, if these calculations were accurate, then the Hubble's constant, which is the rate of expansion of the universe, would drop but reach somewhat of a constant in the future. This is the first possibility and is what we call the Big Freeze. This is also the possibility that scientists think is the most likely, so listen up. Okay, so what the Big Freeze actually means is that the universe will continue expanding forever. The heat in our universe will be so evenly distributed through such a vast space, the universe would go through what is called heat death. Now, it doesn't mean that the universe will become extremely hot, but rather the opposite. Mechanical motion within the universe will no longer be possible, and stars would also be unable to form due to the gases in the universe being spread so thin. With such little energy in the universe, nothing would really happen. Okay, but earlier on in the video, I may have lied to you. While it is likely that the energy density will remain constant at a graph of a to the power of 0, there are still uncertainties with this. It would be more realistic to say that it evolves with a to the power of 0, give or take 0.08. Now, the implications of this are actually huge. Although the number of 0.08 may seem insignificant to you, remember that this is not only an exponential graph, but also means that through time, a small difference in the power would amount to huge changes in values. So it means that the energy density could become either more positive or more negative through time. Now this graph gives a more realistic interpretation of what could happen in the future. Radiation and matter density would go down as expected, while dark energy has some uncertainties associated with its constant value. And this brings us to our two final possibilities for the universe. Okay, firstly, what would happen if the energy density was even bigger than we had previously expected, because of the added uncertainties? This would mean that the expansion would be at a much faster rate. The very fabric of our universe would be torn apart. Black holes, stars, and our own galaxy would all be ripped apart, leading to its name, the Big Rip. This would result in a bunch of single disconnected particles composing our universe. A model made by Marcello Visconti even suggests that the rate of expansion would eventually become infinity. Now, this graph shows the three possibilities of the universe and how it will affect the size of the universe with time. Now, the one in the middle, it is when the dark energy is a constant, and it is the big freeze I described where the size of the universe is increasing. Now, the one above it, it would mean that the dark energy is no longer constant, but rather increasing, and this is the big rip. You can see that the rate of expansion of the universe is much higher. But what about the one at the bottom, where we can see the scale of the universe actually decreases with time? That is called the big crunch. The big crunch is actually the opposite result of the big rip. This is when the energy density is actually smaller than we had initially assumed with a to the power of 0. Imagine the universe expanding to its maximum and then suddenly collapsing on itself because the gravitational pull is stronger than the dark energy. Essentially, this would be the opposite of the Big Bang, as everything would implode back on itself and into a small point. This brings us to another theory, which the universe is cyclical, and when it all goes to a very small point, this is when the Big Bang would occur once again, and it is what we call a big bounce, and the cycle would all begin again. Needless to say, there is so much more complicated physics behind this, but at least this will give you a basic idea on what you can expect to happen. But also remember that this won't be happening for billions of years, so rest assured you'll be okay. Thanks for watching.